So let me start. First of all, thank you so much for inviting me. Juraj, thank you so much for finding me. I'm very glad that I have an opportunity to share my knowledge, share my experience about Traefik, about the Kubernetes, about the entire cloud native world. So today, my presentation is entitled Routing Microservice Architectures with Traefik. And just let me briefly introduce myself. My name is Jakub Hajek. I'm based in Poland. Currently I'm in Warsaw, in my home office, and I'm working from here right now because of the situation in Poland and actually in the entire world. And who am I? I'm a technical consultant. Currently, it's called DevOps engineer, mostly SRE engineer, because I have a sysadmin background. I've been working for a couple of years for different companies in Poland, as well as in abroad. And mostly I was responsible for keeping environment in a good, healthy condition. So that was my responsibility. And currently I'm running my own company. I am trying to do the same. However, we are actually providing more services, especially consultancy. We are doing workshops from the different technologies, especially from the Elastic Stack, Kubernetes, and entire DevOps, because we try to implement DevOps culture into the organization. And from the December, I'm Traefik ambassador, and I'm giving a few talks about the Traefik and how we use Traefik, what you can do with Traefik, and why it's so cool. So what's the aim of our presentation? I will go through theoretical slides for a few slides. What is the Traefik? How we can use it, what we can do with the Traefik. Then I will give you a live demo based on the Canary deployment. This is what I would like to present to you today. We'll try to deploy a service. We'll try to migrate that service to the newest version, and we'll see what happened because it will be live. Today I upgraded the environment so everything can happen. Hopefully it should work correctly. Keep fingers crossed. So where is the service? We can ask the question when we deploy our small service, even Nginx, in our large environment. We don't know where is it. We need to know. We need to expose it somehow to our customers. And in the past, I work a lot with HashiCorp tools that are exactly great, and I use Nomad, Consul, and Console templates. I had to write Jinja templates that are a part of a virtual host for Nginx, and Nginx discovered that there is a new service that has a more containers running in the background in the backend to solve the content. So it was a quite, let's say, difficult. And Nginx is great, still a great tool. We use it very often. However, it wasn't designed for solution and cluster orchestration tool we have right now. So now we have a Traefik. And Traefik, what is it? Traefik in a nutshell. It's just a edge router. What I would like to remember from that slide, it's not the web server. It's not responsible for serving a static content. It's just a router that you install on the top of your infrastructure on the first tier, and the responsibility of Traefik is to publish the service to your user, to internet or even inside your local network, because you can have a multiple scenarios. So basically speaking, it's a kind of a reverse proxy. The same feature you can use in Nginx, but Traefik has been designed to work with cluster orchestration tools like Kubernetes, like Docker Swarm, like Mesos, or any other. So it's one single binary that you can even install on old-fashioned bare metal servers, because we have a few projects that, because of some reason, have not been yet migrated to the cloud or to any other more flexible environment. They are still fixed on the on a bare metal servers, and you can easily install just a binary, simple binary, and have lots of advantages that comes from Traefik. So I strongly encourage you to give a try of the tool if you haven't tested yet. So what is the architecture of Traefik? Because we can talk about how it's great, but what is the basic architecture? So once you install Traefik on your infrastructure, once you deploy it, you have something like entry point. An entry point, that it is basically speaking a port or ports that you can open, and from that ports, user can enter to your infrastructure. Once user enters your infrastructure, once the request itself enters your infrastructure, it will hit router, and router it's automatically created, can route the HTTP request or TCP request or UDP, because it supports many protocols, to your service. When you define the service, router can route the request to service, and then service can easily pass the request to the backend server. So as I mentioned, it can be a container, Docker container, or it might be even a virtual machine, because you are still on a little old-fashioned infrastructure. And from that slide, what is the very important, that we have a middlewares, and middlewares can tweak any request, any incoming request and outgoing request. And we can define multiple middlewares. For example, basic authentication is a kind of a middleware, and those middlewares can be easily assigned on a routing level. So it's a great solution. I like it very much. We use that in many places, in many applications that we've been working so far. So the key features of Traefik. So we have you can still find a lot of environments where someone deployed version 1. So it's a crucial change if you are talking about version 2. And I will just briefly mention these key features and crucial changes comparing version 2 to version 1. But now let's briefly have a look at what are the key features of Traefik. So as I mentioned, we have an automatic service discovery. Once you deploy a service in your infrastructure, let's say it's a Kubernetes service, it will be easily discovered. And if you can scale it up horizontally, because you are scaling up, you would like to have more containers, it will automatically discover that there are new containers, and those containers will be added to the backend, actually to the service, and will be responsible for handling incoming HTTP traffic. So that's the perfect, because you don't have to create any templates like Jinja templates that I mentioned a few minutes ago about talking about the console and console templates, because everything is done here automatically. So that's the great feature. Few lines of code and you are ready to go. So Traefik integrates with major cluster technologies. As I mentioned, Kubernetes is now most of the popular, but I'm from the Docker Swarm world, because we use a Docker Swarm world for and it also works perfectly. So it integrates with multiple cluster technologies. It has built-in metrics, so you can expose the metrics in open metrics format for Prometheus, and then you can create beautiful dashboards in Grafana to visualize what's happening in your server, in Traefik server itself. It has an integrated Let's Encrypt, so it's perfect because you don't have to install anything extra, and Traefik can easily issue new certificates for the services you have created, and also can make sure that those certificates are not expired. So you don't have to create any custom solution. Of course, you have a cert manager, but it's already built in. You don't have to install anything extra. As I mentioned, it's a HTTP router. However, it supports other protocols. In version 2, the team has added other protocols like TCP, UDP, and gRPC. So you can have we use, for example, TCP in with Elasticstack when we work with a Logstash. There is a Lumberjack for transferring logs. So how to create routing and scale it up, you can use the Traefik for it. So it's a great match. And of course, middleware. As I mentioned earlier, there are multiple middlewares. It will be a slide that is that will be a list of a few middlewares. But in the versions, you will be able to write your own middlewares. If you cannot find the feature that you would like to apply to your request, you can code your own. So it's a flexible, a very modern reverse proxy edge router. So what is new in the version 2? Because in the previous version, we had a front end. So front end, this is the part that is exposed to the internet, and a backend. And rules, that is something that can tweak a request. But in version 2, we changed the naming, and we have a router, we have a service, and we have a middleware. So this is very important if let's say you are trying to maintain an environment and there is version 1 installed, so it's totally different to the version compared to the version 2. Both versions are nowadays supported by Containers, the company that is behind the Traefik. However, if I were you, if I will make a decision right now, definitely I would go with the version 2 because it will be developed and will be much more new features. So in the version 2, this already implemented Kubernetes CRD, so custom resource definition. You can still use a standard ingress, but it's not such a flexible as it is right now with a Kubernetes CRD. And I will show you in a few minutes what you can do, how you can install CRD, how you can deploy Traefik, and how you can create the services, an entire configuration using actually objects, custom objects created by that configuration. So, as I mentioned, middlewares, they are fully customizable, so you can create a lot of middlewares, and those middlewares can be reused on many routers. So you define one middleware, and you can easily assign that middleware to the other router. So repeat yourself. Traefik has as well as version 1 and of course version 2. It has an added dashboard, so it's a beautiful UI, and you can see how your services are defined. So you can also show to your C-level management, okay, let's have a look what we have deployed. This is how it looks like. It's a very nice dashboard that you can see what is deployed. You can even use it for troubleshooting, of course, for basic troubleshooting, but it's nice to have it. In the version 2, you need to create HTTPS by default for it and create basic authentication, protect that user, protect that piece of code, piece of dashboard to allow to see only by authenticated user. In version 1, you can just display it and it was not secured. In version 2, there is a feature that is called Canary Deployment. I'm sure that you have heard a lot about the Canary, but it's built in Traefik, so it's a nice feature. It can be done through the service load balancer, and today I would like to show it how it works. It also has a mirroring, so again, it's a less popular, less common feature, but you can copy a request to your user to the service, but the response is not sending back to user. So let's imagine that you deployed a service that is, let's say, not unhealthy, and once you send an HTTP request, you received any 500 response. So those responses are not to the users, and you can test your application on live production environment. So it's a nice feature. And of course, session stickiness, so you can stick that you can create a rule that each incoming request that will travel through your router will be sent to the same instance. So it will be not load balancing and round robin between all instances that are up and running in your service. So this is the stickiness. Sometimes application needs that feature. So that's the already implemented. And all these features are in the open source version. And there will be a few, just only 2 slides that there are, because Traefik is also enterprise edition, EE. And if you are enterprise company, you are looking for a professional support, you are not relying on open source, and you're looking for the reliable solution, they have a EE version. So it's already clustered, because if you are working with open source version, you need to prepare a high availability solution based on your experience, and it's a little tricky, especially if you use Let's Encrypt. But it's not I can talk a little bit later about it if you you'd like to learn more about it. So, but EE, it's already, it's fault tolerant, and of course it's supported. Some of the companies requires that, and maybe you should definitely be aware that there is a kind of an option. High-level architecture of EE. So we have the controllers, we have the proxies. So we have the 2 components that are separated. In open source version, it's everything built in one binary. In EE, you have a separate component. So it's a little different, but it's worth to know that it's another option if you work with Traefik. You can start with version open source. In your test environment, you can prove to your C-level guys, okay, it works perfectly. Then you can consider maybe we should think about moving to EE, because we have a business mission critical application. So what's the Traefik configuration? It will be a very simple diagram, because we have two types of the configuration. And second is a dynamic. So as it is the name, static is something that you cannot modify without restarting the traffic. Everything what is dynamic, like creating routers, like creating new services, new middlewares, and issuing certificates, everything is done dynamically while the traffic is up and running, so without affecting your users. So that's the very nice feature, that it's done dynamically, and even if you will create new changes using services middlewares, configuration statements, no one will be affected. So it's very nice that this is implemented. From the left side, if you are going to open new port because you are looking for another entry point, you would like to add another provider, like let's say file provider and maybe a Kubernetes, you need to restart your Traefik server. However, it starts very quickly, so you shouldn't be it just starts very quickly because it's a one binary, so it just works, right? So this is what you should remember from the slide, that you have two types of the configuration. And in my examples, I will show you what are the major differences and how it looks like. And yeah, I talked a little bit about the middlewares. Now I will just give you a few examples of the middlewares and what you can do with that. So by default, you have a circuit breaker. So if you, let's say, have many services already implemented and they are starting to fail because of any reason, so the environment is getting unhealthy, and you can have a fallback server that you can redirect user to the fallback server. So it's nice feature that you can by default on the router level. You don't need any extra servers to do that. It's already implemented. So fallback system in case of real problem in your infrastructure. Forward authentication, this is actually what I like very much, because you can authenticate your users in a separate authentication server. Let's say I can authenticate all my team members in our Slack channel. If you are already logged into Slack, I will show you the service, because if you are not logged in, you will receive 403, forbidden. If you're authenticated in Slack, you can see the content. So it's a nice feature that you can pass the request to the external server that is responsible for authentication. Another very important, very nice automatic retries. So let's say your backend is working very slowly and Traefik didn't get the response. So you can send another request to have automatic retries. But it's a kind of extra features. Response compression, if you forgot to add the compression to your server, Traefik can manage that for you. So it's pretty nice feature. And headers. In my example, I will be using headers. So you will see how you can add headers to your request. You can add headers also to your response. So it's actually how you can add requests to your response, not to the request. So there are also many more middlewares, and as I mentioned, in the upcoming version of Traefik, you will be able to code your own middlewares. So it's a part for someone who is a good developer. You can code your own middleware and create some extra features that are not yet implemented. The list of the all available middlewares are in the link here. So about the middlewares, let's have a look on the CRD, because what objects have been created using CRD. So once you deploy CRD, you will get a few specific custom resources. The first one in ingress route. So once you use the object, the kind actually that is called ingress route, you are creating HTTP routing. So it's an abstraction layer for HTTP router. You will see an example how it works in a few minutes. Middleware, again, is another object that has been created. It tweaks the HTTP request. So that's how you can use it. And if you would like to, for example, basic authentication, that will be one of example, you can definitely use middleware. It's an abstraction layer for HTTP, for mirroring, for load balancing. So it's nice to have it. Ingress route, TCP, and ingress route UDP, as the name stands for, it's for TCP and UDP services. All the list and why they decided to use a CRD instead of using standard ingress controller, you can read in those two links that are placed in the bottom of the slide. And Canary Deployment and Traefik. So this is what I would like to present you. A few words for those who are not familiar. What is it, Canary Deployment, and why we are using that in our work? So as you can see on the picture, you can see the coal miner who is keeping the bird. The bird, it's canary. The bird is keeping in a cage. And in the late 20th centuries, coal miners used to use birds to find out the dangerous toxic gas, especially carbon monoxide, in the coal mines. So they travel down to coal miners with a bird cage, and once the cage was distressed, it gives a information to coal miner that something is happening and probably there is any toxic gas. So it gives a time to escape from the dangerous place. The bird gives a time to escape from the dangerous place, and coal miner can be saved. So we use the same approach once we deployed using a Canary. So we deploy one service, and we don't redirect each incoming request to that new service, but we are testing. We see what's happening. What are the responses? What is the performance? Of course, you have a specific KPI, service level objectives already defined. If so, we can see what's happening on that one container, let's say one container, and it gives you a high level overview what would be if you migrate everything to the newest version. If you notice, okay, there are some problems, you can easily roll back. So the same situation, you can escape from that situation and try to fix if it is the problem with your service. So if you are talking in the technically, once we are talking about the Canary deployment, we need to distinguish what is the deployment and what is the release. So we can deploy many versions of our application service on our environment, but it doesn't mean that traffic will be routed to all those deployments. Once we decided that we are switching to this particular version that we deployed, we are making a release. And if we understood correctly that approach, we know what is we use that in Canary approach, Canary deployment approach. So just deploying two versions, and we are slowly trying to migrate entire incoming traffic to the newest version. Of course, if there are any errors reported in the newest version. So maybe you can understand it in that diagram. So we have a traffic, we have a Canary created, and majority of our users are routed to version 1. So this is the stable version. This is actually the old version, but now we decided, okay, let's deploy version 2. So we deployed the version 2 of our app, of our service, and we just only a few users can go to that version. And if you have a good monitoring solution, good KPI created for your application, you can notice what's happening in version 2. If everything is fine, you can proceed with the deployment, actually with the releasing to the version 2 by completely switching to the version 2. So this is how it's designed in general with a Canary approach, and this is also the same implemented in Traefik, and it will be a part of my demonstration. As I mentioned earlier, there is also a mirroring or live traffic shadow. Because what's the difference between Canary and mirroring? In Canary, if we have some bad requests in version 2, something is not stable, our response will be sent back to our users. So our users will be affected. Of course, just only a few of them, but still they will be affected. In mirroring, we are not sending response back to our users. So that's the feature that you can use it if you are just deploying a new version of your application. You are releasing, but no response are sent back to users. So you can see how it is stable. If it's stable, you can proceed with your Canary approach deployment. So it's a nice feature to test service in the real production environment. And as you probably know, it's difficult to keep the many environments up and running. And in the most cases, they are not coherent. So production is always has lots of resources. It's powerful. In most cases, staging, test, QA environment, they are less powerful. They are not, in most cases, coherent with a production. So even if we test something in the staging development environments, QA environment, the results will not be the same as we are going testing in a production. So I don't encourage you to test your app fully on the production, but you should notice that it's not the same. If everything works fine on QA, it doesn't mean that it will be working correctly on production. So using a canary approach, using a mirroring, you can prepare yourself for the final release. And of course, you can automate all these processes. So yeah, so this is how you can manage it. And as you can see here in my slide, this is how mirroring looks like. So we can send a 20% of our users to version 2, and even if there is any problem, no response will be sent back. And I'm aware that it's just a diagram. It's in the real world, it's not easy to implement it, but we should develop our application in order to use that feature. Of course, if there are any databases in the background and we use any crude comments, it's more difficult. So your application should be aware that it's designed to be cloud native and to be designed to work with that feature. It's sometimes you need to make a decision if it's worth to do that. So this is the question for you, but definitely it is worth it. So what is I'm finished with my slides. Now let me switch to my terminal, and what I'm going to show you today, it's just a briefly what is my demo environments in details. So I already set up a cluster using a K3s, so it's a lightweight version of Kubernetes. The cluster consists of 3 nodes. There are 2 domains created, alabs.commentary.eu and clabs.commentary.eu. So on alabs, I deployed dashboard, and on clabs, we will try to deploy test application using Canary approach. Hopefully, everything will be working correctly. Those 2 domains, they already have set it up. They're using a DNS round robin from Route 53. So we are sending a request to HTTP request to, so they have a multiple A records. So we use the old feature from DNS to use a random A records. So in fact, random IP addresses, and send the request to those 3 nodes. In case of problems with one of the node, we have a health checks created in Route 53, in AWS Route 53, and we can easily remove that A record. So I encourage you to have a look on it because it's nice feature. How I set it up, K3s cluster, it's just the 2 comments. It's pretty simple feature, pretty simple to install it in just on the VMs you have created. Just you have a few 2 comments to run. I encourage you to use a parameter no deploy traffic, because in the current version, there will be deployed version 1 of traffic, and we don't want to work with a version 1. We will deploy traffic using our own code. So 2 comments, and very easy to set up Kubernetes cluster that is in most cases very consistent with a standard Kubernetes KA8S. So talk is cheap. Show me the code. Let me turn off my keynote and let me switch to my Visual Studio. Of course, the code will be published, already actually published. I did some changes today, And in order to, if you have a cluster, set it up, first step is to run CRD, custom resource definition. So as you can see, there is a few objects that will be created once you deploy it. So we create ingress routes, we create middlewares, TLS options, TLS stores, and TCP, and also a UDP. So this is what have been created and coded by containers team. I haven't coded.
Jakub, make it bigger, please. Bigger screen.
Sure. Is it better now?
Yes, thank you.
You are welcome. So this is just the code that have been created by containers. I just deploy it, and you have to do the same. Once you deploy, use those objects in your configuration. So it's pretty nice. So I will not go into talk more about it. Just deploy it, of course, in a separate namespace, because it's a good approach to keep everything in a separate namespaces. There is also a role-based access control to all of those objects. So again, it has been just deployed, created and deployed by containers team. So nothing more here. Let's focus on the traffic, and here will be more, I believe, more interesting for you. What I've created here, I have a deployment. I created deployment. So it's a standard Kubernetes object, and with that object, we will install Traefik. So we will install the latest version of Traefik, and we are passing a few arguments, so some parameters that are added to the binary. And as you can see, what is commented out, that means that you can use a CLI comments to keep your configuration much simpler. And everything can be listed here in as an argument. So it's nice to see that if you are reviewing the configuration, if you are reading the configuration, but as an option, you can create a file provider, actually a file that is a file provider for your configuration. And in my example, this is what I'm going to use. So I will show you in a second what is the inside that file. And I strongly encourage you and recommend you to use health checks for everything, every service you are creating, because we need to tell our orchestrator where, when, and in what circumstances our service is healthy. So Traefik gives you a specific endpoint that is called ping. So you can run the ping command every few seconds, and if you receive 200 HTTP response, your service, your cluster orchestration tool can think, okay, everything is fine with my container. If no, it will be trying to restart, recycle the service. So this is already implemented. You don't have to craft anything by yourself. Of course, resource limits, and I expose three actually entry points. So one for HTTP, another for HTTPS, and another for Traefik itself to expose the ping endpoint. And I use a few volume mounts because, as I mentioned, I need to have a storage for Let's Encrypt certificates because I use a Let's Encrypt in my configuration, and also for config for the file I just presented you a few lines above, and also for custom configs, because again, I would like to present you the most, maybe not difficult, but I would like to present as many features as I can from Traefik. So that's why I use a extra conf.d for specific files. Of course, you don't have to use it. You can just create everything in CLI comments as it is displayed here. So it's your option. Keep it simple because it will be easier for maintain. I use a node selector to deploy traffic on one particular node because of the storage that I use for traffic certificates. It's not replicated across my cluster. You can say that it's not high available. You are right. EE provides that solution. Traffic Enterprise Edition provides that solution by default, and you can use it if you of course need it. Or you can think about how to create fully high available, fully reliable environment, even using open source, but it's not available by default. 2 ports that I expose and targeting to the names I created previously, because we use a service, load type of load balancer service to expose the ports, the internet from traffic. PVC standard configuration. There is nothing fancy here. Let me show you the configs, because that's the important. And let me go up, and I use a config map to pass the configuration in TOML format. So we use entry points that I displayed above. We use a log level format in JSON, so you can now forward your logs directly to, let's say, Elasticsearch, and have create nice diagrams. API, so this is actually the dashboard that I mentioned. I disabled insecure. Actually, it's secure, so the flag is commented out. Ping, just a one parameter to inform traffic that we are expecting to have any health check. And providers, so I defined 2 providers: file provider, because we use the configuration from file, and CRD, Kubernetes CRD. We are also exposing the metrics using the open metrics format for Prometheus, and 2 certificate resolvers. One is a staging environment. Actually, this is a staging environment, and it's so if you test your installation, definitely try to use, you have to use staging Acme server, otherwise you will be blocked, because sometimes you don't correctly, and if you are trying to send many requests to Acme, you will be blocked. So you can define multiple certificate resolvers and use staging for tests, for your tests. And another config map that I created for extra configuration. So we use a TLS settings. We use a middlewares that I created. So I created 2 middlewares. Moved the X powered by and a server, key value header, and some security headers. So using that name, you can assign security headers middleware to your multiple requests. So it's a piece of code that can be used. So in my opinion, it's a very nice feature. Yeah, let's focus on the dashboard. So what do we have here? We have again standard service from Kubernetes that is pointing to the port 9000, and it's just for dashboard. And what we have here, we have the first time we use the new custom object that we use from CRD. So the name is ingress route. So what we have right now here, we use a specific metadata just to label everything, to have everything structured in our cluster. We expose 2 entry points, and we use routing here. So this is how we define routing. So as you can see, there is a rule created in that line that use HTTP host header. If your request sent in HTTP host header that value, you will be redirected to that internal service in Traefik. Because on that domain, we would love to have dashboard. That's why we are redirecting to that service. In other examples, in a few minutes, you will see how we redirected to custom service, to custom application we create. And of course, we use a certificate resolver for Let's Encrypt. And middlewares. So as you can see, I use a middleware, and the name of that middleware is out. So what is in that out? Let's have a look. So first of all, I've created the standard Kubernetes object that is a secret, and I encrypted here username and password because I would like to protect I would like to have dashboard for available only for authenticated users. So that's why I created that secret my middleware. So let me, okay. So here I'm creating the middleware custom object, and the name is admin out. So the name is out, and I refer that it's a basic authentication, and I refer to my secret created in a previous file. So now I can use that middleware many times in my routings to repeat that. So it's very nice to have that possibility.
Sorry, check your time. You have about 5 to 10 minutes, okay?
Yeah, okay. Sorry. So we have a speed up here. We have automatic redirection from HTTP to HTTPS. We have an ingress route for catching everything and to redirect from HTTP to HTTPS. Let me show you the dashboard because this is the nice feature. I already deployed that configuration, and we have a dashboard available at the domain. So we have 3 entry points that you were able to see. We have a routers in my config files, and we have a services. All of them are internal because we haven't deployed any application yet. We have those middlewares that I created, and as you can see, 2 of them are provided from file, and another 2 are from Kubernetes extra custom objects. Yeah, so it's deployed, it works. So now let me deploy my code, my Canary to our application. So we'll have two simple V1 and V2. First, we'll deploy version 1. So let me first check whether my cluster is up. Hopefully it is working. Yes, it is. Let me apply our code files. So it is creating, yeah, deployed. Look on the Canary here. So we have a web application that is just running a container on the port, on that port, and just display headers. So just a specific regular deployment. And we use here the service because we would love to expose it. And ingress route, that application should be available at that port. Let me try it to see whether it's now available, but first let's refresh to see if there are new routing created. Yes, it's created using the web app. The name is web app, and this is that routing. What we have here, we have a host, we have a available entry points, and of course, let's encrypt. Let's see what are the services available. and 2 containers are available to handle incoming requests for that server. So let me see what is inside. CLabs commentary EU. Yeah, application is up and running. And now what we would like to do, we would like to release version 2. So first we need to deploy it. So let me see the configuration file. I'm creating another service, another deployment with version 2. So nothing fancy, just changing the image comparing to the previous. And another service, the name is web app v2. And now we are creating a middleware to assign specific HTTP headers, because we would like to, in order, Canary approach works, Canary deployment works randomly. You cannot have any influence in default configuration to route the traffic to v1 or to v2. So in order to do that, you need to have Canary, you need to have specific headers. And I use a request header knock knock and the response header hello there. So let me go here. And here I'm creating a weighted service between web app v1 and web app v2, both running on the same port. And another ingress route using the same matching rule. And using the same matching rule, but once I send the header, Canary header knock knock, I should be redirected to the v2. So let me first deploy it and let's see what's happening. It is deployed. So let's go back here and see if we have another new router created. Yes, we have, because there is a 7 right now. And we have a new route that is the host, and second is a regular expression based on the header. So if we find that header, something, it should match that rule. And let's go to service to see what's happened. As you can see, we created one weighted load balance, weighted service that is balanced between 2 web services. And what are the weights? 3-to-1. So it means that the majority of the users will go to v1, and the only a few of them will go to the version 2. So let me try to refresh. We should expect that the version should change after refreshing. v1, v1, v2. So Traefik randomly routed us to the v2. So yeah, it works. But now we would like to test the version 2, because we would like to be sure that our application is working correctly. So we can add extra HTTP header in order to be redirected to the v2 using the rules I created in my middlewares presented here, right? So I need to add that header. So let me see if that worked correctly. So I created a basic curl comment that I'm adding the header, and I'm just sending the request. And first of all, let's check if the requests that header have been added correctly. Into the request, yes, the curl added correctly header. And now in the response, we should found hello there. So yes, that means that we hit the v2. And that's true because we are here and we have a v2. So each time when I execute the request, I will be always redirected to the v2. So this is the feature that you can use if you are going to test your application. You can now create a smoke test and test version 2. Of course, it's a demo application, so it's pretty easy. In the real production environment, that situation looks more complex and is, in most cases, is not such as straightforward as I presented here. So it's all about the demo. Let me just briefly back to my presentation. Yeah, so we presented UI, so you've seen how it works, how deployment. So this is how we've just seen, and the mirroring. Actually, I haven't presented, but I can show you the configuration. It's just another service that you can create. What are the benefits of Canary? So you can test everything in my personal opinion, you can test your application in a real production environment. So you don't have to maintain many environments. It's better in some specific circumstances to test in the production environment and to have a real feedback how our application behaves. And yeah, you have a rollback. You can easily roll back, and this is actually how it works. So I think this is all what I've prepared for today. If you have any questions, you can reach me on Twitter. There is my email, and hopefully you enjoyed my presentation and my live demo. Thank you very much. That's all what I prepared for today.
Okay, Jakub, thank you very much.